In this video, let's see the topic on lateral earth pressure. First of all, myself B. Chelapriya, Assistant Professor Civil, Rohini College of Engineering and Technology, Palkulam. So first one, lateral earth pressure. When a soil mass is retained by a retaining wall, the soil mass tends to slide. So due to this, the pressure may be exerted on a retaining wall. That pressure is called as lateral earth pressure. Next one is backfill. When a retaining wall is constructed to retain a soil mass, the retained soil mass is called as a backfill. Next, the magnitude of lateral earth pressure depends upon the following factors such as type and extent of movement of the wall, properties of backfill materials, groundwater condition, degree of roughness of the surface, slope of the back of the retaining wall and depth of the retaining wall. Next, types of earth pressure. There are three types of earth pressure. First one is active earth pressure, passive earth pressure and earth pressure at rest. So first one, active earth pressures. When a backfill is retained, the slope tends to slide and move away from the rest of the backfill. This means the backfill is push or rotate the wall. So it is free to rotate. The active earth pressure is denoted by the symbol Pa and its units are kilonewton per meter square. So retaining wall, the soil retaining side are called as backfill. Here, due to pressure exerted, the state of stress of soil element is represented by a Morse circle as shown in a figure. So as shown in below figure, where OB is a vertical stress and OA1 is a lateral earth pressure at rest. When the lateral pressure tends to push the movement of a wall away from the backfill causes the expansion of a backfill, resulting the stress release, thus reducing the lateral earth pressure and the diameter of a Morse circle is increased. It is shown in a figure 2 is shown in a figure that is zone 2, that is OA2. Again, with the decrease of lateral earth pressure, the diameter of a Morse circle is increases. When the circle touches the failure envelope, there is a no further decrease in lateral earth pressure takes place. And it is denoted as OA3 in zone 3. Next one is passive earth pressure. When the wall moves towards the front soil, that is front soil, the maximum earth pressure exerted by the soil in the passive state is called as passive earth pressure. Here, the movement of the wall is resisted by the soil and exert a pressure on the wall. So, there is a movement of the wall towards the soil. Therefore, the more in strain in the front soil in the form of compression. So, due to this, the more in lateral earth pressure. Due to more in lateral pressure, the diameter of a Morse circle is reduced. It is shown in a figure, below figure, that is OA2. So, next again with the increase in pressure, the decrease in Morse circle as shown in zone 2 and 3. Further increase of lateral pressure from the soil makes it higher than the vertical stress. So, at this stage, the lateral pressure becomes the major principal plane, that is major principal stress, and the vertical stress becomes the minor principal stress. This is shown in a Morse circle 4, 5, 6, etc. When a Morse circle touches the failure envelope, that is circle 8, the soil in the wedge of failure and no further increase in the lateral earth pressure can take place. So, the maximum lateral earth pressure exerted on the retaining wall when the wall moves towards the soil while it reaching the limiting equilibrium. This state is called as passive earth pressure. So, in the figure you can able to see first OA1, next the failure zone is touches OA9 in the circle touches the failure envelope. Next, earth pressure at rest. So, in earth pressure at rest means there is a no movement or they are fixed in a position is called as earth pressure at rest. When the backfill of a retaining wall which is in fixed in position and cannot move means then it is called as earth pressure at rest. It is denoted by a symbol P0 and its units are kilonewton per meter square. Here, the lateral pressure exerted on the retaining wall depends upon the direction and extent of the movement. So, the earth pressure at rest diagrams are shown in a graph. Next, derivation of expression for earth pressure at rest. When a material is subjected through three-dimensional stress, that is sigma x, sigma y and sigma z along the three coordinates x, y and z representative. So, the strain along the x-axis can be commuted. So, Ex equal to 1 by E into Ex minus mu into sigma y plus sigma z. It is taken as equation 1, where Es is an horizontal strain and capital E is the modulus of elasticity of soil and mu value is Poisson ratio. When the earth pressure at rest, Ex value is 0 and sigma x sigma y equal to P naught. Substituting these values in equation 1, we get Ex equal to 1 by E into P naught minus mu into P naught plus sigma z, which is equal to 0. By rearranging it, we get the value P naught equal to mu divided by 1 minus mu into sigma z. Here, mu divided by 1 minus mu is taken as K naught, that is coefficient of earth pressure. So, the equation 3 is valid for only elastic material, not for soil, because soils are not elastics. So, depends upon the type of soil, coefficient of earth pressure, that is K naught, is different. So, for loose sand, K naught value is 0.5 to 0.6. For dense sand, K naught value is 0.3 to 0.5. For undrained clay, the K naught value is 0.8 to 1.1. For over consolidated clay, the K naught value is 1 to 3. Next one is the coefficient of earth pressure. So, there are two types, vertical earth pressure and horizontal earth pressure. The pressure applied in a vertical direction is due to the backfill laying above it are called as vertical pressure. When the pressure applied in horizontal direction, then it is called horizontal earth pressure. Here, coefficient of earth pressure at rest. So, when the retaining wall is at rest, then the ratio between the lateral earth pressure and vertical pressure is called as coefficient of earth pressure at rest. So, coefficient of earth pressure is, already we have told that in active state means lateral pressure by vertical pressure. It is also, we can write it as ratio of horizontal and vertical principal stress when a retaining wall moves away from the retaining soil. So, Ka equal to 1 minus sin phi divided by 1 plus sin phi, which is equal to tan square of 45 minus pi by 2. Next, coefficient of passive earth pressure. So, it is also when the retaining wall is moving towards the backfill. So, then the ratio between lateral pressure and vertical earth pressure is called coefficient of passive earth pressure. It is also, we can rewrite as ratio of horizontal and vertical principal stress when a retaining wall is posed against a soil mass, then it is called as coefficient of passive earth pressure and it is denoted by a symbol Kp. So the formula may write as Kp equal to 1 plus sin phi divided by 1 minus sin phi, which is equal to tan square of 45 plus pi by 2. So in this video, we have seen about the lateral earth pressure which is existing on the retaining wall and also the coefficients of earth pressures. So thank you.